This is 9.5, solving trigonometric equations. So this section is going to be really important because this is where you're going to be doing a lot of these algebraic or tapping into your algebraic toolbox to really be able to do these problems. So they appear a lot in engineering and physics and in chemistry. So you'll be able to see some of them. So we're going to start off with something really simple. So we're going to start off with the equation cosine of x equals 1/2. So basically what we want to do is what value of x will give cosine a value of 1/2. So remember, cosine takes in angles. So we want to figure out where are all the possible angles that will give me 1/2. So one way that we can do it, which we've kind of already learned, is by taking cosine to both sides, cosine inverse to both sides. So if I take cosine inverse, then I'm just going to get x by itself, and x is going to be equal to the cosine inverse of 1/2, which equals pi over 3. But that's only one solution. We know that the cosine is 1/2 at many different types of angles. So from the unit circle, we see that it's actually also in quadrant 4, which is 5 pi over 3. So if I go to the unit circle, and we know that the cosine is x, well, we're going to look at all the x values. We see that the first x value where it's 1/2 is pi over 3. So that's one of them. The other one is right here. And that one is 5 pi over 3. So here are two solutions that you are able to get within the unit circle. So in the unit circle, there are two solutions where the cosine is 1/2 at pi over 3 and at 5 pi over 3. So the solutions in this case would be pi over 3 and 5 pi over 3. But that's only in the interval from 0 to 2 pi. Because remember, the unit circle, so everything that you look up in the unit circle is always going to be from 0 to 2 pi. So this is from unit circle. Okay? And these are the only two solutions that you obtain. However, if let's say you wanted all of the solutions, so even if I were to add 2 pi many different times, how can I figure them out? Well, all we know is that if I have pi over 3 right here, and if I add 2 pi, or 360 degrees, I'm going to get another solution. I add another one, I'm going to get another solution. Okay, same thing with this guy. This guy, I add another one, and I'm going to get another solution. So there's infinitely many solutions that I can have, okay? So what you can do is, if you want all possible solutions, okay, that exist, all you got to do is just either add 2 pi or 360 degrees to both, to your solutions. So for example, if you only wanted it from the interval from 0 to 2 pi, the solutions would be x equals pi over 3 and 5 pi over 3, and you're done. So if I said I want all of the values for x that give me 1/2, then this will be the answer within the interval 0 to 2 pi. If you wanted all solutions, then basically what you got to do is figure out what were the two solutions that you got, which was pi over 3, and then we're going to add 2 pi to it, because every single angle of 2 pi of a term added to 2 pi is going to give me a coterminal angle. But now I'm going to put this k there. Remember that this k can be any number. So if I wanted to know two cycles from now, then I can just plug in k equals 2. So it'll be pi over 3 plus 2 pi k, and then x will be here 5 pi over 3, so wherever that guy is, plus 2 pi k. And here, remember, k is an integer. It's just a number. Okay, so this actually will be the full solution if I wanted all solutions. Okay. All right, so here I kind of wrote theta, whatever your value of theta is, plus 2 pi k, and k here is an integer. Okay, so you have to be very careful. So if you only want solutions within an interval, then you might want to look at the unit circle or use reference angles to find the remaining solutions. Okay, so sometimes the problem will not be on the unit circle, and I'll show you what to do in that case. Sometimes they will. Okay, and if you want all solutions, find them just the same way, but now you're going to add plus 2 pi k. All right, so I will give you, when I do problems like this, you will have either this guy or you will have either this guy. So I will tell you, give me this one from 0 to 2 pi, or give me this one from all solutions. Okay, so here let's do an example. So solve the equation sine of t equals 1/2. Okay, so first we want to do it in the interval from 0 to 2 pi, and then we want to do it for all solutions. First one, what we want is the interval from 0 to 2 pi. So that means that I have to look at the unit circle if the value is there. So here we have sine of t is equal to 1/2. Okay, we can use inverse sine if we want to, but I think it'll be easier to just look at the unit circle and figure out what angles are going to give me 1/2. Okay, so remember, sine is just a y value, so let's look at our unit circle and figure out where I get 1/2. Okay, so let me go ahead and erase this guy. So, because we don't need this. So we want to figure out what angles are going to give me 1/2. So, so first, we remember sine is the y value, so here's 1. So you're going to get pi over 6, okay? And then where else is it? It's right here. And that's going to be 5 pi over 6. So you have two values, pi over 6 and 5 pi over 6. So in this case, it'll be pi over 6 and then 5 pi over 6. So here are the two angles where the sine is equal to 1/2. Okay, now what about if I wanted all solutions? Well, what I gotta do is I gotta take the first one, pi over 6, and I'm just gonna add 2 pi k to it. Okay, the second one, I'm gonna take 5 pi over 6, and I'm also gonna add 2 pi k to it. Okay, and here what you want to write is k is an integer. Okay, now a little shorthand notation in case you don't want to write k as an integer continuously, you can write this fancy notation, k, then like this funky looking sign, and then a z. What this means, so this z, let me tell you what this means. So you got a z, and then kind of like a little bold, okay? So this k just means k lives, so this is where it lives, or is an element of, this is a way to say integers. Oh, I misspelled integers. Okay, integers. Okay, and this guy just means lives in, or is an element of. So if you don't want to write k as an integer over and over again, you can just write this. Okay, whichever you want. If you want to be a little fancy, you can do this guy. K is an element of the integers. Oh, this is just how we write integers in math notation. But if you just want to write k as an integer, that's completely fine. But I just want to give you two different ways to do it. One with a really fancy notation. One is just the regular way. Also, one other thing, sometimes you might get degrees. So if I wanted to get everything in degrees, then obviously these guys will be the same thing as degrees. It will be what? 60 degrees. So if I wanted in degrees, so, and the way that you will know if it's degrees, I will say t is between 0 and 360. So that's really what I would say. Okay, so when I look at my unit circle, what I'm going to be looking is as a 30 and 150 degrees. So you would just say that t is equal to 30 and 150 degrees. Okay, so that's only if you were to see this in an interval. And if you write it this way, then you would write 30 degrees plus 360 degrees times k, and then 150 degrees plus 360 degrees times k. And here, obviously, k is an integer. Okay, so this is just in degrees. Okay, just in case that does happen. Typically, a lot of the times, I will just ask you what is the answer in radians. But just in case something is in degrees, you'll know what it is. Okay, so what about this guy? So solve the equation in the interval 0 to 2 pi. Okay, so here you have more things that you have to work with. So the first thing that you really want to do is imagine that you want to solve for x. Okay, so what you're going to do is you're going to solve for this sine of x. So you want to get this guy by itself. So let's subtract by 1. So you're going to get 2 sine x is equal to -1. And then let's divide by 2. So sine of x is equal to -1/2. All right, so now what we need to know is what angles are going to give me negative 1/2. So I'm going to go back to my unit circle. Let's erase all of this. And now we're looking for negative 1/2. Okay, so negative 1/2 for sine is going to be right here. That corresponds with 7 pi over 6. And then the other one is right here, that corresponds with 11 pi over 6. Okay, so it's going to be 7 pi over 6 and 11 pi over 6. Now, in this case, since we only wanted it in an interval, this will just be my solution. You don't need to write plus 2 pi k because you don't want all of them. In this case, we just want the regular solutions. Okay? So now, what about cosecant of theta? Okay, well, what is cosecant? Well, cosecant is just 1 over sine of theta. Okay, that's what it is. Okay, now what I can do is I can multiply both sides by sine. So this goes away, so I'm left with 1 is equal to negative 2 sine of theta. And then I just divide by the negative 2. So I get sine of theta is equal to negative 1/2. Okay, you can see here that you actually get exactly the same thing as before. So actually, I already know this answer. Theta is equal to 7 pi over 6 and 11 pi over 6. So we already knew what the answers for that one was. Okay, it was just kind of like in a cosecant form. So if you have cosecant, cotangent, or secant, it'll be better to turn it into the reciprocal forms, into sine, cosine, or tangent, because then it's easier to work with. Okay, now what about this guy? Well, first we have a square. We don't want to be dealing with squares. So what we want to do is let's apply a square root to get rid of the square, because that's the opposite. So we're going to apply square root to both sides and add plus or minus. Forget about the plus or minus. So you're going to get secant of x is equal to plus or minus square root of 4 is just 2. So remember, secant in this case, if you think about the reciprocal identities, is the opposite of cosine. So it's the reciprocal of cosine. It's going to be 1 over cosine of x equals plus or minus 2. Okay, you can move the cosine over to the other side. I'm going to move this cosine over. So what you're going to get is 1 is equal to plus or minus 2 cosine of x. And then I'm just going to divide this plus or minus 2 to the other side. So I get plus or minus 1/2 is equal to cosine of x. So basically what I'm looking for is where exactly is the cosine of x positive 1/2 and where is it negative 1/2. Okay, so what are all the x values where it's positive 1/2 and negative 1/2? All right, so let's look at the unit circle again. Remember, cosine is my my x value. So we're looking at all the positive and negatives 1/2. So here's a 1/2, here's a negative 1/2, here's a negative 1/2, here's a 1/2. So what are all those angles? Pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. Okay, so pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. So those are all my possible angles in which I can find, or in which the secant squared x is equal to 4. Okay, so sometimes there might be multiple angles that you got to plug in. Okay, so you have to be very careful. All right, so in the next video, we will do some more problems that are a little bit more involved.